This is section 8.3, proving triangles similar. There is a difference between congruence and similarity, and it's that the sides are proportional. In congruence, the sides are congruent. In similarity, the sides are proportional. So two polygons are similar if and only if all corresponding angles are congruent and all corresponding sides are proportional. I have two polygons below. They're actually triangles, and I want to determine if the two triangles are similar. Well, angle A is 28 degrees, and angle F is 28 degrees. Angle B is 130 degrees. Angle E is 130 degrees. Angle C is 22 degrees, and angle D is 22 degrees on the smaller one. So we have corresponding angles that are congruent. We're halfway there. All corresponding angles are congruent if we let A correspond to F, B correspond to E, and C correspond to D. Okay. If that's the case, let's make sure we line these up correctly. AB, which goes between the 28 and the 130, would have to correspond to EF, which goes between the 28 and the 130. So my first proportion would be 6 divided by 3. Then BC goes between the 130 and 22, as does DE. So would that be equal to 10 to 5? And then finally, AC, which goes between the 28 and 22, would have to correspond with DF, which goes between the 28 and 22. And so hopefully we would find out that all these proportions were the same. Well, 6 divided by 3 is 2, 10 divided by 5 is 2, 14 divided by 7 is 2. So all the corresponding sides are proportional. Even though they are not congruent, they are proportional. This triangle is twice as big as this triangle. Now, look up here at the top. How am I going to write a similarity statement? Well, the way that we show that polygons are similar is by using a tilde. It's like the top of your congruent statement. You've got an equal and a tilde. Well, we don't use the equal part. We just use the tilde to say these are similar. Remember how these are matching up. We've got the big triangle is going to be triangle ABC. It's going to be similar to the smaller triangle. Match them up. Angle A goes with F. Angle B goes with E, and angle C goes with D. So triangle ABC is similar to triangle FED. Determine if the two polygons below are similar. Write a similarity statement. Wow, I already did that. Let's move on. Example 2, determine if the two rectangles below are similar. If so, write a similarity statement. Well, because these are rectangles, they're all 90-degree angles, and so no matter how I match them up, corresponding angles will all be congruent. I'm off to a good start. It looks like the shorter side here is 5 and the longer side here is 6. If these are similar, the sides are proportional, and so 5 over 6 would be equal to 3 over 8. Should be rather obvious that those two aren't the same. 5/6 is more than a half, 3/8 is less than a half. We can also cross multiply. We get 40 is equal to 18. That's clearly not true. These two triangles are not similar. Exclamation point. Just as there are ways to prove triangles congruent, and hopefully we remember those. We had side, 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 angle, 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 side, hypotenuse, leg. Well, there are different ways to know that triangles are similar also without having to do all 6 parts. We have 3 parts for 3 different ways to do triangles, and in fact one of them only takes 2. The first that we have is called the angle-angle similarity postulate. It states that if two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. Not congruent, but similar. Angle, angle, angle did not work for congruency, but angle, angle, angle does work for similarity. If you have two angles congruent on a triangle, you know the third corresponding angles have to be congruent, so it really only takes two. All right, so let's prove these two triangles are similar and then write a similarity statement. Well, in order to show that these triangles are similar, I have to have two angles that are congruent. One of them is very easy. I have two 36-degree angles. That's a good start. I need to find two more. Well, holy cow, I have vertical angles. Angle ACB is congruent to angle EDC. So therefore, those two angles, whatever size they are congruent. And so by angle-angle similarity, I know that these two triangles are congruent. Now I'm going to call this X and this X. I'll call this Y and this Y to make sure that I match these up to write a similarity statement. Triangle ABC is similar to triangle. Well, A corresponds with E. B corresponds with D. And C corresponds with C. So triangle ABC is similar to triangle EDC by the angle-angle similarity postulate. That is amazing handwriting. I'll teach you to do that one day. Number 2, the side-angle-side similarity theorem. Side-angle-side, that's the same as triangles. Don't get confused, though. In this case, we're talking about a congruent angle, a congruent corresponding angle. Now the sides, instead of being congruent, the corresponding sides around those angles don't have to be congruent. They just have to be proportional. If they're proportional, the two sides that make up the angle have the same proportion, the angles themselves are congruent, that's enough to say the triangles are similar. So let me prove that these are similar, the HGI and LJK in some way, shape, or form. I have the angles, 118 degrees already there. GI to HG is equal to 2 to 3. JK to LJ, GI, HG, JK, LJ is equal to 3 to 4.5. Are those really the same? Probably the easiest way to do that, other than try and cross multiply, I'm going to take the bottom and I'm going to multiply the bottom by 2 over 2, and I will get 6 over 9. I'm going to multiply the top by 3 over 3, and I will also get 6 over 9. 3 is 1.5 times 2. 4.5 is 1.5 times 3. These two sides are proportional. Therefore, the two triangles are similar. Make sure I match them up again correctly here. Triangle HGI is similar to triangle LJK by side-angle-side similarity. This time it's a theorem. Well, why didn't I prove it? I'll prove it after the on the fourth problem of the video. Can't have a theorem without proving it. That being said, example 5 I probably won't prove. I may leave that for us to do in class. Number 3 is the side-side-side similarity theorem. Yes, we have a side-side-side congruence. This is side-side-side similarity. Now all three corresponding sides don't have to be congruent, but they do have to have the same proportion. All of them have to have the same proportion. So in this case, instead of going across the triangles, I'm going to go from side to side. And here I'm going to go 2 to 3. Is that equal to 3 to 4.5? And is that equal to 4 to 6? Well, we already know 2 to 3 is equal to 3 to 4.5. Why? Because I did it just a minute ago. Also, if you cross multiply, 2.2 times 4.5 is 9. 3 times 3 is 9. These two are proportional. What about over here? 3 times 6 is 18. 4 times 4.5 is 18. These are proportional. Well, clearly, if the first two are proportional and the 2 and 3 are proportional, then the others the first and the third, have to be proportional also. It's pretty easy to see that 2/3 is equal to 4/6, so those sides are proportional also. All three corresponding sides are proportional. That means that these two triangles are similar. Triangle IGH is similar to triangle KJL by the side similarity theorem. Once again, I probably won't prove this. If we get time in class, I'll prove it there. Understand, you could have done these in a different order. You could have said GHI is congruent to JLK, similar to JLK, would still be perfectly fine. Now let's try some on your own. Problem 1, determine whether the polygons are similar. If they are, write a similarity statement. Pause your video and try this now. In this problem, the sides are certainly proportional because this is twice as big as this, 6 is twice as big as 3, but I've got a problem. I don't know anything about the angles. To illustrate my point a little bit more, this could have been a 2x3 rectangle. Let's put it in the right order, a 2x3 rectangle. I have no way of knowing. This clearly is not a rectangle. These may or may not be similar. I have no similarity statement I can write. The best thing for me to put here is not enough information. Try number 2, determine whether these triangles are similar. If they are, write a similarity statement and then state the postulate theorem that proves. Pause your video and try it now. At first glance, I see these sides and I get pretty excited. Maybe these sides have to do something. But remember, I have side angle side and side side side. In this case, I only have one S. One S isn't going to get me anywhere at all. Well, what about two angles? I've got one angle. I've got a 90 degree and a 90 degree. The other one's 46 and 44. But before I give up, remember the triangle sum theorem says these angles have to total up to 180 degrees. How much more do I need to make these be 180 degrees? Sure enough, this one's a 44 degree angle. Now I have two angles that are congruent, and so the triangles are congruent by angle. So I can write triangle PQR is similar to triangle, let's get this right, there's a 90 degree angle, there's a 46 degree angle, there's a 44 degree angle. Triangle PQR is similar to triangle UTS by the angle-angle similarity postulate. Yes, I'm getting a little lazy. That's the angle-angle similarity postulate. And I wrote the similarity statement. Let's try problem 3. Once again, determine whether the triangles are similar. If they are, write a similarity statement. Give the postulate theorem that proves it. Pause your video. Try this now. In this particular case, I have two sides. I would like to get the third side. I would be tempted to try the Pythagorean theorem because this looks like a right angle, but I don't know that it's a right angle. I really can't use that yet. But I will use these two sides. If I only knew the included angle, everything would be great. Well, holy cow, look what I've got. I've got a line here. I've got a line here. These two lines are parallel. Because those two lines are parallel, I hope you've been able to hear me on this microphone. Because these two lines are parallel, these are corresponding angles. The corresponding angles postulate tells me that these two angles are congruent. If that's the case, I now have, as long as these proportions are right, is 4 to 6 the same thing as 6 to 9? Well, 36 is equal to 36. So they are proportional. These two triangles are similar by the side angle side similarity postulate. Triangle UVW is similar to triangle WXY by side angle side similarity. I think I said postulate a minute ago. This is actually the side angle side similarity theorem. Fortunately, I am not an electrician, so therefore I am going to continue on and do problem